Okay, folks, so I wanted to do an example of how to calculate loads on a project. So what I've done is laid out a simple half concrete, half timber building. Looking at the elevation, there's this low timber portion, the roof steps up, which relates to the framing looking like that, and then a three-story concrete portion. So because my recording didn't quite work, I've got this part done at this point. So let me just walk you through how I did this. So I like to just start from top to bottom, and I didn't do that perfectly. So I just identify each component. Looking at an architectural section is really nice because it'll provide that information for us. And then I just start working through line by line. So this is from my book, and it's just a quick, easy reference for me. So it's also in your PowerPoint for the load. So you can come to this table, which is essentially the same data. So if I'm looking at roofing and we have shingles, I see that it's 2 pounds per square foot, and that's for one layer. So I'm going to double that because roofs always get re-roofed. So I came here, wrote in 4, and then I come over here to the sheathing. Where did I have that? Plywood. So 3, so that could be OSB or plywood. That's 3 pounds a square foot per inch. Most roof sheathings around a half inch or 7/16, so I'm going to take half of that, and I had 1.5. For insulation, I come here to loose fiberglass. I'm going to say there's a lot because that's energy wise and efficient, so I'm going to say it's 6 inches times 0.5, and that gives me 3 pounds a square foot. The framing, I came to this next page here and said to myself, okay, I'm going to assume they're 2 by 12s. It's 16 inches on center. That gives me roughly 3 pounds a square. And then I doubled that for beams, columns, which is probably on the high side. So that could be a little less. We don't want to super overestimate dead loads because they actually benefit us for overturning loads. So anyway, framing the ceiling I got from chipboard here. So 5 pounds a square per inch divided by 2 because most gyp is half inch. If it's a firewall, it's going to be 5/8, and if it's a burly firewall, there's going to be 2 to 4 layers on it. So we want to pay attention to what the architect's doing. Then I added 4 pounds a square for mechanical, electrical, and plumbing. Added it all up, got 21. Hopefully that's right. 6, 10, 11, 12, 13, 14, 15, 16, 17, 21. Okay, cool. Then I did a quick one for concrete. So if I come in here, the roofing is 1 pound a square foot. That's again from the book. For the slab, I use this prelim design table in concrete, which is in your concrete structural system PowerPoint. And if you're in another class of mine, like steel, there's going to be a similar table in there for you. So this kind of says, all right, if I have a one-way slab in a 15-foot span, so I come here, I broke this 30-foot span up and put a beam there. So from here to here is 15 feet. So I come here, table says 8. I could also calculate it. Much past 20 feet, one-way slabs just don't really make a lot of sense because two-way slabs are more efficient. So I could say I'm either a two-way slab at 6 or a one-way slab at 8. I don't want to make that decision now, so I'm just going to use 8. So I've got 8 inches. I've got 8/12 to get it into units of feet, which play over here nicely. So 150 pounds per cubic foot, which is the density of concrete with a little rebar in it, times 8/12 gives me 100 pounds per square foot. Okay, so with that said, let's move on to live loads. So I'm going to go back to the book, and this is all the data in your PowerPoints from here. So if I come here and I say, all right, common live loads, So I'm going to say this is a small rural hospital. So hospital here, it's kind of hacked up. It's kind of hard to see, isn't it? Okay, so anyway, we got hospital here, 80 pounds a square for corridors, 60 for operating rooms, 40 for patient rooms. So I'm just going to write all three of those down just so I have it listed and I don't have to go back to some source. So I keep doing that. All right, it's that simple. Let's move on to snow. Okay, so at this point, I need to know where my building is. So to make this simple so I don't have to jump over to the computer, let me just pull out the snow map in ASCE 7, and then we can get into it that way. So here we go. Or actually, you know what? I can use this table, so let's see if they have Utah. I've never seen this before. It's kind of cool. So I'm going to say you know what? I don't really like this table. Mainly because I don't know how to use it. Hold tight. Okay, I figured out what I was doing wrong. I was in the commentary, so no wonder I was confused. Okay, so this is the snow load map, ground snow load for the United States. You can see most of Utah's case study. But let's say our structure's over near Moab, which I think that's kind of what that's telling me here. So below 4,500 feet, we're 15 pounds a square for ground, and above or up to 5,200, we're 20. So let's go ahead and do the higher elevation. We'll say it's 20 and just kind of work through it from there. So I have my PG is 20 pounds per square foot. So if I go back to my PowerPoint for loads, or in this case the book, I can see the equation for snow load, which I want to find roof snow, which is what P sub F stands for. So I have 0.7 CE CT importance factor times the ground snow. We're going to say that's, well, I guess we need to get that because we're a hospital. Bad choice on my part. Anyway, so let's find CE and CT. So again, this data is from the book, but also in the PowerPoint. I'll stop saying that because I think that's obvious at this point. So I need to first off decide, am I urban, suburban, am I open terrain? I'm going to say this is out in Moab, and who knows, maybe it's open terrain. The architect hasn't, or the owner hasn't decided on the site yet, so I'm just going to be a little conservative. I'm going to say it's partially exposed, so my CE factor is 1.0. Then I'm going to come over here to my CT, maybe lift that so the glare goes away. So I'm going to be 1.0, but just to review, this would be structures that are cold, unheated structures, or freezer locker type structures. So my thermal factor is 1, which basically means the snow melts on the roof like a typical building. And then we need to find our importance factor for snow, and if I can do that quickly. So we're category 4 because we're a hospital, and so we're a factor of 1.2. All right, so with that information, I can just put this all together. And I'm going to write it all twice. 1.2, PG is 20. And we'll do that really quickly here. Let's see if I can put this where you can see it. 0.7. That's kind of hard to see. There we go. 1.2 times 20. It's like there's a dog hair. 16.8 pounds per square foot. And in the building code, there's some minimums. But if I remember, it is 10 pounds a square. So we're going to say we're okay. Would it be worth just double checking? I don't see it right offhand in the book. So anyway, it's worth checking the building code to make sure you're not violating some minimum load. But that's our snow load. So we'll go ahead and pause here and start up a new video so these don't get too long.